haven't like finished that video, so I need to also like because of work and all of that, I need to finish that video. But one thing that I need, like I do have a question, but it's not really a question, it's just like a request, you know. If it's possible that we can, maybe today or any other session, you know, in the future, that we can connect some of those, because those two materials, those two contents, like the videos for this week, they are very technical. So like if it's possible to, and the focus, I understand the focus was on the technicality, but if it's possible for you know AI Saturday Lagos to help us connect that, the theory, to like practicals, like for example, now I want to know something like, if we have 25, if we have a data set and we're trying to build a linear regression to be specific, for example, now, and we explore, and we have 20 of the features are numeric, right? 20 of the features are continuous. Do we now have to ensure that all of these 20 features have like normal distribution? Do we have to do this for the 20 of them before we build our model? Like those are things that I didn't get from that distribution video. Like I really want to know what is the, I know that it is important, but I don't know why it is important. Let me put it that way. We know that, for example, maximum likelihood estimation, I know is very important, but I need to know why. What do I need it for? When I'm writing my code in Jupyter Notebook, where am I going to apply it? How would I apply it? That's what I just wanted to, yeah, bring up. Yeah.
Okay. All right. Thank you very much. Thank you for
Thank you very
thanks.
much.
Yeah, thanks so much for that. Well, all right, okay. Let's see how that goes on. So okay, like if you like Teju said in the like Teju said, if you watch it, after you finish the Banali lecture now, you would have seen you would have seen how how it works in practical. I think was it who was asking for the Excel sheets? Who was asking for the Excel sheet earlier?
I am.
So you if you are watching YouTube, you would have seen how the stuff work. But regardless, notice but we'll see how to make everything work um before the end of the session today. Okay. So okay, I guess we should. Okay. Uh, Probably I think we should let us start. Okay. Give me a few minutes and bring up my screen. Assistance, and I don't know what my assistance is like to do. Okay.
Hello?
Hello. Like, I'm trying to bring up the stuff. My system seems to be lagging. Apologies.
Hi, good morning. I just wanted to ask a question.
Okay.
Yeah, so I know I'm already late with the last assessment, but because I had like a hell of a week. But I wanted to know whether it's still possible to submit it by the end of today. Like if the link is still accessible.
The week 7 assessments.
Yeah, this one that's on non-linear modeling.
Non-linear models.
Yeah, this.
Okay. Okay. Reach reach message me privately on Discord.
Okay, okay, thank you. All right.
Joshua, okay, okay, Joshua, let me understand where you are at the moment. Like, okay, I think I saw your message, but you can let me understand your where you are coming from exactly. You were talking. Can you just unmute yourself and speak? I'm not hearing you. Okay. All right. Okay. Um, Welcome everyone to week 8 of the court. Well done, everyone. Those of you that are already in teams, do you know why your team members are not currently on the call at the moment? Any idea?
Yeah, I think like my own team members will probably join. But maybe they just join later because they don't usually join early. So I
Okay.
guess they might, yeah, yeah. Like BC now, I'm expecting him to be here. He's always here. So I don't know, shall we see? And Samuel too is always here too. So Samuel just might come a bit late, but he's always
Okay.
present. Yeah, yeah.
Okay. All right. Okay. Joshua, you can proceed. Joshua, are you there? Oh, so I think we lost Joshua again. All right. Let us. Okay. 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 Before. Okay. I think I should just. How many of? Okay. Okay. Let me just. Okay. Let me drop the poll and see. Okay. I want to know for those of us who I want to know. Yeah, those that watched the videos. So Joshua, I cannot hear you. When you're ready, you can mute yourself, but I can't hear you.
Can
So
everybody?
okay. Okay, your voice is breaking. Well, I think I heard you for a split second there.
Okay. I said so. I joined for the issue was as of the time the cohort started. I That was the week I went for orientation camp, and also
Okay,
almost immediately I had to go to work, and then I had to start sorting out my PPE issues. So I'm
okay.
just settling and I'm just getting myself. So what I wanted to ask was, being that what's it called? The court has progressed to even week 8 or I think week 9 now. Is there a possibility I'm still able to participate in the project?
You thing is, it depends on how is your knowledge of machine learning previously.
You said I didn't get the question.
I said, how is your knowledge of machine learning like so far?
Um, I think I worked on one or two projects, but not like the technicality is what I want to understand
Okay.
for myself.
Yeah. Okay. You can join. The thing is, we didn't split people into teams. Everyone chose their team. So
Okay.
you can. So I think you can just introduce yourself on the. Are you on the Discord channel?
Yes, I am.
So you can introduce. You can just let people know you are. You need you like. You're in search of a team. So if there's any team that has a vacancy, they can, accommodate you. Or if there are other people that still haven't found a team, probably on the Discord channel, then you can just like join them. Do you get? So you can.
Okay, thank you.
But the thing is, to get a certificate, while we started it, was said that so there are a couple criteria to getting the certificate, which is what I am kind of bothered about. Okay. Okay, can you see which can you see the which what are you seeing on the screen?
Yeah, I can see GitHub and the
Okay,
tools and password. Yeah.
okay. Um okay. Okay. This is the certification requirements. 60% minimum attendance, like 40% average assessment score, and 100% participation in the final project. Mm. But one thing is okay, but one thing I'm still not sure is we can still, depending on your special case now, we can decide to like review that, but just try as much as possible to participate in the project.
All
So
right, all right.
I don't know. So you can plead your case. Probably you can plead your case later, but just participate in the project, and not just for the certificate of participation, just to for the knowledge. And you can also you can come to this. Okay, let me share this link in my.
Yeah, okay.
So you can come to this link. You can come here and you'll see all the materials for the cohort so far from week 1 to the current week we are in, which is week 8. So, and you can try to catch up. You can try to catch up so that while doing the project you know exactly what you are doing. Is that good? Is that okay? All right. Back to the polls. Okay. 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 So I want to be sure. I want to be sure every one of us on this call already belongs to a team and have submitted their projects. But if you
Hello?
haven't, hello?
Yeah, sorry. I just wanted to make sure ask a question. The spreadsheet link that Mr. Ju sent, is it for the naive base? Is it related to maybe her naive base what do they
Lecture.
call it? Yeah, lecture.
Yes, 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 yes. It was
Okay.
used towards the end of the
Okay.
since most of us did not watch, since majority did not watch the second lecture. Ah, you know what? Since most of us did not watch the second lecture, we might probably do a watch party. I don't know. So I don't. But let's see how it goes later in let's see how it goes later in the call. All right. So let us proceed to. Yes, let us. Okay. Okay. So for the sake of everybody that watched, and for the sake of those that also watched, yeah. Okay, I think we've done the polls and okay. So what do you understand? What do you understand by probability? Please unmute your mic and talk. We've all okay. This I I mean, I expect everybody to be able to like participate actively in this aspect, since most of us said we watched this. So yeah, what do you understand by probability? Yes. Oh, what's talking?
I think probability is simply the likelihood of an event occurring. Likelihood. That's just the main thing there. How likely is it for something to happen? That's what probability is.
Okay. Okay. Anybody, thank you so much. Anybody else wants to give it a shot?
Yeah, I think is the possibility of the outcome of any random event.
Okay. Okay. Thank you very much. Okay, well, uh, first of all, probability, okay, as our lecturer said, probability is the chance of an event occurring. But what is now, so what are, okay, I guess many of us don't really need this, but I just decided to like do this. So an experiment is any process that there is an outcome. So that's an experiment. And yeah, okay, let me give a scenario now. Okay, in explain this experiment, sample space, and events, can you explain it to me in terms of okay, probably rolling the die, rolling a coin, flipping a coin. In terms of a coin, rather.
Sorry, I didn't get your question.
Okay. I said what is this? What would be a okay, tell me a sample space. If I'm rolling okay, if I'm rolling two coins, what would be the sample space? What can be the sample space? If I roll two coins at a time,
If you
what will be the
if
sample
you
space?
if you're tossing two coins at a time, like at the same
Yes.
time, then sample space can be head, head
Mm-hmm.
tail, tail
Mm-hmm.
head, and tail tail.
Mm-hmm.
So four
Okay.
possible outcomes. Yes.
Okay. So what also for that now, what can be an event? What are the events that we can possibly generate from that?
And the events can be like head, like just one element in that space. I
Any
mean that's what I'm
possible
thinking.
outcome. Yeah.
Yeah,
Mm-hmm.
yeah. Just head, tail head, something like that.
Okay.
Just an element.
Okay. All right. Thank you very much. So, an event now, an event can be okay. What is the probability of getting a head? What is the probability of getting at least a head? Okay, if I'm rolling two die, if I'm flipping two coin at a time, what is the probability of getting a head?
Like exactly a head or at
Mm-hmm.
least a head. Like if it is
Just
exactly
the
a head,
Exact. Yeah.
it
I
is
think it's
two
that's
over
half.
four. Half,
That's
yeah,
half. Yeah.
half.
that's what.
Two
Half.
over four half.
Okay. Are we all agreeing with that? What about what about at least a head?
That should be 0.75.
And
Yeah,
how do you arrive at that?
3/4.
3/4. So the only not possible outcome will be the tail. So that's 3/4.
Okay. And how many sample space do we have?
Like sample space is like four now. Like isn't that?
Exactly.
Oh yeah, like
Yeah,
four.
yeah, yeah. Exactly. Okay, before we proceed, does anybody understand what just happened? Abi, do we all understand what just happened? Or we should, we should take it, a little bit slower. Please, are we on the same page? Okay. Please, if you don't get, please let us know so that I won't just assume everybody is, we're on the same page. So okay, as we all said, the set of all is the set of all possible outcomes in an experiment is known as the sample space. So flipping two coins, that's head, tail, and tail. So and any subset E of the sample space is known as an event. So as we said here, why this thing do you like? Okay, as we said, so an event. So you can looking at this coin. Okay, if I said if I'm asking that I want to know the sample the event of rolling a coin that has a multiple of 2. What will be my answer? Tell me the answer and how you arrived at the answer.
Sorry, do you mean a coin or a dice? You said multiple of
Dice.
two.
Yes, dice. If I'm rolling a dice and I'm expecting numbers that have a multiple of 2. What what is my probability?
So I
Half.
think it should be half now because 2, 4, 6 multiples of 2.
Okay. Does everybody agree with that? I'm not seeing
Yes.
a
Yes.
reaction.
Yes.
Okay. All right. Thanks so much for that. So because if I want to get if I want to get if I want to get them, so we first list out the possible outcome. What are the number of possible outcome? So if I'm looking for the multiple of 2, I can only have 2 itself, 4 and 6. But what's the total number of outcome? The total number of outcome I can have is 1, 2, 3, 4, 5, 6, which is 6. So I have 3 over 6, which is also half. Okay. Okay, from a dice now, can anybody think of another scenario, any other event before we just move on? Okay, let's just proceed. So okay, realize the situation where probability shines. Okay, yeah, I'm not promoting gambling, but yeah, probably if okay, can anyone just explain how probability shines in gambling in this field? Yeah, so anyone just give me a scenario.
I mean, it's the same way for like cards, for example. It's very similar to the dice too, because like even with die you're still gambling. So cards too is similar. There's a finite number of joker cards. There's a finite number of queen cards. There's a finite number of ace of spades, diamonds, and all of that clubs. So there's probability of pulling of playing a particular card when other people have these other cards or something like that.
Mhm.
With like sports, just Nigeria now, like with sports now, there's the probability that they play several types of bets, right? There's a probability that
Mhm.
a team will win a match or not win a match. There's a
Mhm.
probability, that this team will score a number of goals or not or something
Mhm.
like that. So yeah, the same thing. Rain, the weather. Okay, let me pause there. I see because you said
Okay.
gambling.
Okay.
Yeah,
Okay. And
yes.
okay.
Yeah, so just to add to what he said, like in sports betting, like the probability of it's or something happening is categorized by like what's termed like the odds. So they just give
Mm-hmm.
out odds like to represent, okay, how possible is this event likely to occur, something like that.
Okay. Okay. Thank you very much. So, okay. Thank you so much. I just wanted us to be able to like, I want to be sure we understood what we did and to be able to bring it into like real life scenario. Okay. What about weather forecasting? Weather forecasting. Anybody wants to give it a shot? There's no perfect answer, though, but just tell us how you think probability comes into weather forecasting. Or if it is finance you want to talk about, or machine learning. Pick one and just talk about it. What's happening? Oh,
Okay.
volunteer.
In weather
For weather,
forecasting,
okay.
probability can be
Okay.
used in weather forecasting to actually say if it's going to rain or if there's going to be sun today, based
Mm-hmm.
on some data. That's it.
Mm-hmm. Okay. Yeah. Thank you very much. Mm-hmm. Anybody else wants to go another? Or I should just proceed. Who was speaking
Yeah,
before?
I wanted to talk about weather because weather data are also very, you can't tell.
Mm-hmm.
So it depends on probability. After
Mm-hmm.
looking at the data itself, whether a certain
Mm-hmm.
event, whether it's
Mm-hmm.
going to be sunny, it's going to be cloudy, it's based on certain, and so that helps to predict. But sometimes it's not starting itself because at the
Okay.
end of the day, other variables come into play that thing may now come exactly the way it has been predicted.
Exactly. Thank you very much. So yeah, the two I think it's on actually two. They really did a good justice to gambling. So and I guess for everyone that might have dabbled into bet Nigeria, they will understand what they meant, even like on a deeper level. So weather forecasting, so, like we cannot say for sure that rain is going to say, but we can say that we can ascertain to a certain degree.
No
We
problem.
can say that okay, sorry, sorry. We can say to a certain degree, we can say that to a certain degree, this particular it is going to like rain. So since finance too, you can use it to stock price prediction. So okay, let's say okay, this stock is looking at the data. So you're looking at the data over time, looking at occurrences, looking at the news. You can say, okay, this stock is about to you can decide okay, this stock is about to like go bullish, or this stock is about to go bearish. So you decide if you want to sell or you want to buy. So it also helps you to understand the perfect entry level, and it also tell you okay, now it's time to it's time to it's time to walk away. And also my AI machine even in all this even in our language, in all this language model, ChatGPT and stuff, they predict their next token based on probability. I mean, okay, I said token. Okay, yeah, you might not understand token, but let me just say word. Let me just say word. Because if I am talking about token, I have to like I'm going through a lot of things. Let me say word. Okay. So they predict the next word based on the they consider all the previous words. Yeah. Okay, okay. Do we all remember where we did n-gram, right? How many of us remember where we did n-gram? Have we all forgotten n-gram? Okay, okay,
Was
okay.
it in NLP?
Yes, yes, yes. What we're doing NLP, that NLP week. Yeah. Okay, so okay. Let me. It seems most of us have forgotten, but let me just do a brief. Let me just do a brief recap. So in NLP, I said you calculate there's also called 1 gram, 2 gram, and 3 gram. And like that. So you calculate the next word based on okay. Let's say welcome to AI Saturday Lagos. So you can just say that okay, if I'm using 3 gram, I can check the probability. Okay, based on the 3 words, welcome to AI. Then I said that okay, based on these words now, what is the best token we can pick. So there will be a series of words, and I can say okay, you can welcome to AI infrastructure, welcome to AI Saturday, welcome to different stuff. So okay, but there will be a lot of words, but based on this context, okay, what is the next one? So that's basically how probability works and stuff. And if we still remember it won't be it won't be tired. So okay, how do you know that a model is performing well? Okay, this is not major. Okay, and how do we know that a model is performing well? Does anybody
Uh,
wants to give it a
I the first way, I mean, one way is by measuring performance, like evaluating with scores, like if it's a regression model, like MSC,
Mhm.
RMSC, and the others. So, but you can also tell that a model is not performing well if the performance on, you know, the 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 evaluation sets, like the test sets, is
Mm-hmm.
very poor compared to the performance on the training sets.
Pretty
So
set. Okay.
uh,
Yeah. Thank you. Um. Yeah.
Okay, let
That's
me answer
actually.
that, sorry.
Yeah. Mm-hmm. Who was someone else was speaking?
Yeah, so sorry. So,
Okay. Yeah.
so
Proceed.
yeah, so like rightly said, so we have metrics, performance metrics, so model metrics, like you mentioned, RMSE,
Mm-hmm.
aim, those ones. But and as well, so if you are beating the model, you're actually beating to solve a problem. So we now have the business metrics. So sometimes
Mm-hmm.
you can have a low RMSE, for example, and but to the business side, it's making sense to them. They're actually seeing they're actually seeing results. So in a practical
Mm-hmm.
sense, yes, you look at the model metrics, but also look at the business metrics. Is it meeting what the customer wants? Is it meeting their needs? You can have a model that is giving you like maybe like 70% percentage, and and it's performing well for that businesses and actually making money in that regard. So I'm just speaking to looking at the business metrics as well. So is it meeting the customer's goals too? So that way too, you can also
Yeah.
measure your good performance. Thank you.
Yeah. 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 That makes a lot of sense. Thanks so much, Abiola. Thanks so much, both of you. Who was the person that spoke? The person that spoke before Abiola. Oh, okay. Okay. Okay.
yeah, yeah.
All right. So okay, yeah, thanks so much. That makes a lot of sense. But I also want you to know that there's something we call benchmark, like there's something called industry standards. So every field, every domain has a like there's already said okay, if it doesn't meet this particular level of probably you plot your accuracy. Let's say in a particular domain now. Let's say we are using accuracy as our metric. Let's say okay. Um Currently now we are using accuracy, and the current benchmark is 90%. So that means that whatever you are doing and is not able to like meet up to that benchmark, whatever you are doing is is whatever it's even if it seems to be, even if you feel like it is but if it is not, even what if you feel what you are doing is innovative, if your benchmark, if your accuracy it's not able to beat the bench, it's not able to like reach the benchmark, then whatever you are doing, like you need to rethink it. Though there's something the instructor told us. There is no perfect accuracy. If you see a model that is performing 100%, like it's giving you 100% performance, you should probably it is giving you 100% performance. Know that it is already overfitting on something. There's no way you can expect it to generalize because that means it has overfitted on it. So attaining perfect accuracy is not expected, but because the thing is there are different as someone, I don't know who said this earlier, there are different unexpected there are different scenarios that can come in. There are different things, and we call all these stuff, we call them noise, so noise in data. So there are different issues that can come in whichever stage of your data collection or whichever. So all these things can influence your data. But regardless of whichever noise and whichever or whatever data manipulation you have done, there is a benchmark that you're supposed to are supposed to have, even though we are not expecting a perfect accuracy. I don't know if that makes sense at all.
Yeah, it does.
Exactly. So there is even though we are not expecting perfect accuracy, there is a lower limit that your model performance must not like fall below. If it falls below that, whatever you are doing, you like, even if you even it might not be totally rubbish. You might just need to like rethink your approach and look further into it and see how you can be introducing a novel approach, but at least it should also be able to like, whatever you are doing that doesn't improve um on the benchmark, then it is not worth it. And also, let's say you're in an industry, let's say you're also in an industry now, and let's say your current model, you guys built a machine learning model, and let's say the accuracy, let's use accuracy for example. The accuracy is like 90%. And then you built another machine learning model, probably using more things, using other stuff, and it is not beating your current model. Are you expected to like swap that? Okay, or hell, are you expected to swap that? And if you want to like, I'm asking this question, if you want to swap it, what are the things you might consider? We are all
Can I come
professionals
again?
here. Okay.
Can I come
You
again,
have
sir?
okay. In your organization, you are working as a data scientist. You have your current model as your current model as we are using accuracy. Though, but remember, we want to always use accuracy in real life, but I'm just using accuracy. You have an accuracy of 90%. Then you built another model. You built another model. The one you are currently using that is feeding the customer and the clients, that one has a 90% accuracy. The one you built right now, you've not released it. The one you built, that is like the one you built right now, achieved an accuracy of like 89%. Should you change the new one? Should you like swap the new one for the old one? And should you swap, yes or no? If you are swapping, what should be the reason for swapping? It is an hypothetical question. Anybody can explain. We are all professionals. As long as you have been in this code till now, you have understood a bit of theory and code. So just give it a shot. Let's just understand your thought process. Okay.
Yeah, let me just try because I get where you're going, but I'm not so certain what you're expecting for the answer. But let me just try. I can only give a simple use case. For example, if it is a classification model, for example, if it's a classification model and accuracy of the the former or the current model is higher than accuracy of the newer model, if
Mm-hmm.
you're predicting something like, if you're classifying something like cancer, no cancer, um some other metrics apart from accuracy might be more important, like precision might be more important, or recall might be more important, because it depends on the use case. Because recall, for example, now it measures the ability of the model to actually get to determine who has cancer, like to be certain all the time to say this person has cancer, and which is what they might want to prioritize. So that's like in the case of classification, right? That can be a good reason to swap, because the newer model might have better recall than the old one or something like that. So
Mm-hmm.
something like that, Sha. Yeah, that's maybe just a use case. Sorry.
Yeah. Thanks so much. That thanks so much. I like that. Thanks so much. That is a very reasonable answer. I like that. Anybody else wants to give it a shot? That he
So for
has
me,
looked at this one. Yeah. Proceed.
I'll look at the data
Mm-hmm.
itself because
Mm-hmm.
for if it's the same data, maybe exact, and I run the whole process and I get it tonight, I'll
Mm-hmm.
find what's the reason. But if the data is an improved data and I have it tonight, what I'll do is I have an accuracy of 89. I will revert back to I will what we call in terms of version. If it's in production, I'll move to version 2 because I believe it's much more it's very close to the reality of my data.
Mm-hmm. Okay.
Okay,
Thanks so
sorry,
much
sorry,
for
sorry.
Hello?
Can I say something? I just thought of something too. I don't know, maybe it's
Yeah,
your.
I even wanted to add to what you said. So
Okay, but let me just say
okay.
something there before I go. Sorry. Like, what about if overfitting is a problem? The old model might be overfitting and something like that. Like that measure could be, that measure might not be the accuracy, or the measure might not be a good measure
Yeah.
or something like that. That's the only thing else I can
Yeah.
think of after that. Yeah.
Yeah. Yeah. The
Okay,
thing
so
is, both.
yeah,
Okay.
okay,
okay. I
so
wanted to
now
just
okay,
okay.
okay, no.
Okay. One after the other, please. Who is going first? Okay.
I just wanted to add to what he rightly said. Like, sometimes it's not in all cases where like accuracy might be what you're mainly looking for, even though like that's also like a good metric normally. But
Mm-hmm.
like in the case of like normally when you have like imbalanced data sets,
Mm-hmm.
accuracy might not really be of that much importance compared to like others, like what he said, like um precision and the rest, because the model like might simply be predicting the majority class, which can
Yeah.
achieve high accuracy, but it can also fail at its like true purpose, like in the data set. So that's just
Yeah. Yeah.
Yeah.
Thanks so much. Thanks so much. It is both parties are actually right. You don't look at you don't just look at it from one eye. So first of all, yeah, like accuracy. So you might decide to like okay check. You might decide to okay. As you said, if you need to understand what your whatever you need to, this is where domain knowledge comes in. Okay, you feel like okay, do you care more about the true positive? Do you care more about the do you want to reduce the false positive, or do you want to reduce the false negative? So depending on whichever one you want to reduce, and now the time okay, they now determine your approach if it is precision recall or F1 score that you want to do. That is very correct. And at the same time, the data, you need to look at the data as well. If okay, let's just assume I'm using, let's see, let's assume, like let's forget for a moment that okay, we need to check all this other metric. Let's say we are only the only metric we are sticking with is accuracy. So we need to check the data as well. If my former model now is, let's say
Let
I
me
trained this, sorry, what was that?
Can you hear me? Sorry. So I just want to just
Yeah, I
you
can.
you asked about now how do we go about maybe swapping the model, that should we swap it? So now for that model now, I already have a model deployed and is so far is working. Don't have any issue. But let's not say for some reason I had to be that. Of course, anyway, there'll be reason for me to build new model. So even though I have 89%, so even though I have one better, I have to just I can't just swap it like that, because like I said, there could be noise that can affect my output. So what I can do is maybe I can just try to just do, in this case, maybe A and B test, for example. Have my model running, the 90% accuracy running. Then maybe have some of my customer, see how well this my 89% model does. Do you get the point in real life? Because most times you can have a model perform, not so great, in this sense. Maybe let's say 89%, and is solving a problem very, very well. And you can have a one that's 90% is already overfitting, like rightly said. So I won't just, maybe even though I'm prioritizing recall and the like, so I won't just, just swap, that one my the one that's been working. Like if it's working, don't touch it, just leave it here. If it's working, then just
Mhm.
a problem and chaos.
Yeah.
So
Yeah.
thank you.
Yeah, thanks so much. I really love everybody's submission. I really love everybody's submission. So I'm not sure I've mentioned this A/B testing here before, but regardless, please you can also like read up on this A/B test. So it's just like you doing. Look, I don't know if you have done, if you have done, if you I guess everyone is familiar with ChatGPT, right? So there are times that you might prompt ChatGPT and it will give you two parallel answers, and it asks you to select one. How many of us have experienced that before?
Yeah, yeah, very like almost every day, guy. Like no more. Sometimes you say you'll be confused. Like, I'm asking you for a solution, you're not giving me a problem.
Exactly. So that one is a typical example of A/B testing, like checking which one people will prefer and checking which one performs better in production. So that's just a simple example of A/B testing. That's what we call A/B testing. Does that
Yeah,
make sense?
yeah, thanks for that. I actually never thought of that, too, guy. That makes
Exactly.
thanks for enlightening us, man. Thanks.
Exactly. So that's A/B test. So you can let that be let that be everybody's personal assignment. Even though we didn't cover A/B testing in this particular quote, you can also read up on this. Thanks so much for that submission, Abiola. So that is also another method to like check your model performance. And there's also the one that we're talking about was there was like the data. If you check the data, you see that okay, maybe your initial data now, that your initial data that was your initial model that was trained probably was trained on maybe 90 megabytes of companies data, and then right now your new model you are training it on maybe like 150 megabytes of company data. Even you will know that so this is just telling you that okay, even though it has a slightly less accuracy, hmm, it will actually like generalize. It is expected to generalize more and perform even better, accommodate much more customers demand than the one that is already working at 90%. Do you understand that scenario? Does that make any sense? Ah,
Yeah, it does.
exactly. So please,
Can you please come again? I try to get it right, please.
okay. The current model that your company is serving, it was trained on 90 megabytes of company's data. Hmm? The new model you built that is 9% was trained using like 150 megabytes of company's data. Do you get? What now is telling you that the 150 megabytes of company data is more robust. Like it has lots more data than than the um than the
90.
model that
90.
exactly than the 90% model. Do you get? That is telling you that this one will this one can generalize better. If it's having 89% and it's having 89% and it was trained on a lot more data. So compared to the one trained on almost like half of the data, and
Sorry.
that's performing slightly better.
So are you saying that the larger the data, the better the performance of the model?
Yes.
All right.
Yeah,
Okay.
Yes.
yeah, just to follow up with what he said now, I want to just to follow up what he said now. Does this mean, and to me, because I think I now have an idea where you're trying to take us to, does this now mean, can I say that, or can one say that the 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 larger the data, the more or the less uncertain, can we say that, or the more certain a model is, or less? Can we say
It is
that?
not okay. The thing is, I'm not. It is about. It's not really about uncertainty now. It is more about how like generalization.
All right.
At that point, it's about generalization. Like how like if you it can predict across many scenarios. Like it is not limited. It has a lot of how do I call it now? I don't. It has. It's not majorly about uncertainty. It's not majorly about uncertainty. But the thing is, they are okay. It's also about uncertainty too. If because there will be some scenarios that are present in this new model that were absent in the previous model. So
Mm,
the new model will have like better certainty. Like will be like we'll have or we'll understand to a certain degree that okay, this is bound to occur. Then compared to the one model, the other model that has not seen that doesn't understand that particular scenario. And
mm,
for you to, if you are training if you are training a machine learning model, the even though we want it to generalize, it is still within a specific context that we want it to generalize. If you are training your model on medical and you are evaluating it on probably law or finance stuff, there is no generalization it is doing there. But
yeah.
within that context, it's able to like generalize, and there will be some cases where it will be like much more certain because it can understand the scenario because it can understand the statistical distribution between this particular data points. I don't know if that makes sense at all.
Yeah, so
Yeah, yeah,
sorry,
yeah. I get
just to
it.
be hello?
So,
Yes.
okay, you want to say something?
Yeah,
Please go ahead.
okay, yeah. So just to be clear with what you said, it's like the larger the data sets, like for example, because just like you said, the other one had like, for example, let's say an 89% accuracy. That's the lesser one. Then maybe the larger one is
Mm-hmm.
now having something like a 91% accuracy. But you're just trying to explain that the larger data sets, because the accuracy level is still, it might not be up to um the the other one, but in this case,
Mm-hmm.
it generalizes better.
Mm-hmm. Exactly.
Sorry,
Exactly.
can everyone hear me?
Okay. Yeah, yeah, yeah. Go ahead.
I have a question. How are we explaining generalization here? Is there like a test set that is kept aside, or are we talking in terms of training data set alone? Because I haven't really heard anyone talk about test sets here, or old out sets, or what the size of the data was for the model that is already deployed, and if that has changed or maybe the distribution has shifted. I heard some things around that. So just want to clarify, make sure we're all on the same page here.
Yeah.
Sorry, like, I
Okay.
didn't get that. Like, what, when you say
Okay.
something?
Was that a
Yeah. Okay.
question?
Okay.
Yes,
Yeah.
I
It's
think
a
I think
question.
he was asking you questions concerning
Yeah.
the generalizations of a thing.
Okay.
So
So okay. About the generalized, so I think this is one aspect that I haven't mentioned, as I think Sergio was like trying to bring to our notice. So okay, you in when a particular model is in deployment right now, and you are receiving data from your clients or from your customers, and you receive data. So I think when you get much more data and you feel and your data like the distribution of your data like is drifting from the original data, and then you see that your model gradually, like initially when you built the 90% when you build the 90% accuracy model, when you built it at that point it was achieving like it had the 90% accuracy, but over time now it was now drifting, and the model accuracy was now like reducing because there were because how do we get the data? We get data based on what's the customers and the clients, what's the input, right? So once we see that our model is not, so when our model is not like performing as it's supposed as it was performing, because we are having like new data in our new data, we're having a new distribution, we're having new perspective of data, and because our model was not trained in that perspective, so even though it started at 90%, now it is not like performing as good as it should. I don't know if I do you get that. So now we now train a
Yeah,
new model.
before I go
Sorry,
my question is how in this 90%, is it accuracy on the training data? Like after a while, you check your compute the accuracy, and then you're like, oh yeah,
sorry, we are struggling. I'm struggling to
90%.
hear you, Teju. I don't, is it my network, or is that am I speaking to
We
everybody?
we, we can't hear you, ma.
It's breaking
Your
as well
network
on my
is
end.
breaking. Okay. It's still breaking. Okay. Okay. All right, but okay, let me just let's just okay. What she's trying to say. Oh, I think okay, how I understand what she's trying to say. Probably when our network is stable, she will come up again. So what she's trying to, do you understand that particular aspect? But when we are trying to understand and we want to evaluate a particular model, I want to evaluate both models, both the former one and the new model. There should be what she says, that there should be a uniform like evaluation. Do you get? We shouldn't be evaluating one on the previous data and then the new one on the new data. So this new data that we have, which is the current accurate depiction of our clients now. We should before we can say that okay, this 89% is better one and this 90% is different, we should actually like evaluate both of them on the same data set, on this new data set, and which on this new data set, which shows the depiction of um of the new distribution of what our clients demands now. So that's then we can say, okay, this is a better model and this is not a better model. Even though what we've been saying so much, like I think those are still old, but I think we should what you say that we should still like evaluate both of them on on a uniform on a leveled ground, so we can put them side by side and say, okay, this is the current this is our data. even though the data is still within the same, it's still within the same, what would I call it now? The same domain, I'll be within the same distribution rather. But there are some aspect of the data that the first model is not used to, and then this new model is now used to. So when we now evaluate both of them on this data that represents our represents our clients now, then we can now say to a certain degree that, okay, yes, our model is performing well. No, our model is not performing well. Okay. Okay, I think that was okay. I think that was just for that. So
Yeah,
I
that's what
was
you just explained. Yeah, that's what you just explained now.
okay. So yeah, instead of evaluating both, so I think it should be rather than just like even though the 90% accuracy that we got, other than just evaluating it on the previous on the former data set, it should instead of separating both, it should be the same test data set. So if we are now evaluating both on the same test data set, and the first one is achieving 90% and the second one is achieving 89%, that shows that whatever um whatever confusion that we might have. So does that make any sense at all?
Yeah, I follow. I follow.
Yeah. Thanks so much everyone for the contribution. Thanks so much, Teju, for that as well. So yeah, let's go to these are the different types of events that we have. Okay. Mutually exclusive events, independent events, conditional or dependent events, and we also have complementary events. So these are already like the it's just to explain this, but I also want to bring it out. So mutually exclusive events is that okay? You can they cannot happen together. The occurrence of one means that the other one cannot happen. Just like this, it's just the same as tossing a coin. You can either get a head or a tail. If you are tossing a singular coin, you can either get a head or a tail. You cannot get both. So if you get one, that means you cannot get the other. Okay. So independent events say that okay, the occurrence of one does not affect the other. So tossing two separate coin, you can have a head. If you have a head, doesn't mean you have a head. If you have a head, you can have a head. You can also have a tail. So it doesn't affect each other. They can have similar occurrence, which is head, tail, but they don't. So which is okay. If you're in a situation in independent events where you have let's say you toss two coins and you have like head and tail, what do we call that kind of scenario where you have both the same, where you have both like similarly? I think that's okay. I think because of time, I think that's called intersection. So like they have similar. They are similar. You are getting similar results, which is it can be head and head. It can also be tail. So conditional or dependent events. So drawing cards without replacements. If you draw, okay, let's say you have a stack of cards from 1 to K, 1 to 10, then K, Q, J. If you rem- if and that's your stack of cards. If you remove a key if you remove a card without replacement, if you remove a key, the next time you are drawing a card now, you can never expect to withdraw a key because it is no longer part of the distribution. It is not okay. I'll come. It is no longer part of the it is no longer part of the distribution. Is that clear? Am I still speaking with people here? Am I audible?
Yes, you're audible.
Okay. Okay, thank you. So that is what we know about conditional display. So drawing cards without drawing cards without what's it again? Without 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 replacements. Yeah. So now, okay, complementary events. Let me. Oh, yes, also, I want to go to this. I want to go to this line. Okay. I don't know why this laptop is. Okay. So does anybody okay now? Okay, let me come back to complementary. Does anyone know the difference between this mutually exclusive events and complementary events?
Okay, but to answer this in linguistics way, is it right?
Okay, just give it a shot. Give it a shot. Give it a shot.
Okay. Should I go?
Yes, please proceed.
Okay, Abdul Shakur, please go ahead.
Okay, based on my what's it called? Understanding of mutually exclusive events is more like two events cannot happen at the same time. Like more like if event A happens, event B cannot happen, but event B can actually happen if event A doesn't happen, something like that. But when I look at complementary events is more like if once event A has happened, event B can never happen. If it's more like the example they use here now, rain and no rain. If once it's raining, automatically we know that yes, no rain cannot. The probability of no rain is zero automatically. But for what's it called for mutually exclusive, you can actually pick in a what's it called? You can actually pick. You can actually have edge and have queen, but you can't have both at the same time. Something like that.
Okay. Thank you. Okay, okay, proceed. It's
Alright,
my
alright. Let me just say my own. So, here is the thing. Like, this is what I understand about mutually exclusive. Then I will explain it in the linguistics aspect. So, when we say something is mutually exclusive, that take a two letters for it. For example, so letter B, sound B and sound P. So they are two different letter, right? Having different features. So if you put them in the beginning of a particular vowels and another consonant, they give you another meaning entirely. So if you change the letter B with P, it changed to another word. So the B and P are mutually exclusive, so they cannot occur in the same environment. Do you understand? So, and for complementary distributions, like complementary event is like they are like similar to that sound. It's just like as Hausa man will call fa for pa. So fa and pa are serving the same feature in the same environment. Like instead of saying people, you say people, Hausa man will say fifo. So fifo and people in the same way they are complementary distributed. You understand? So that's what I could say about that.
yes. Thank you very much. Thank you. Thank you. I really
Hello.
appreciate it.
Yeah.
Yes.
Yeah, I just wanted to add to what they said. So I also think that a close call difference might be because complementary is also a kind of special case for this mutually exclusive. But I think when, just like what the other girl said, that if the probability of something happens, either if this one is happening, it means the other one can never happen. So I think also in that measure, like the total probability like possible outcomes for like those two events, like of it happening and not happening, it sums up to one. Like that's for the complementary. But for the mutually exclusive, the probability of like just like when you're explaining this dice, like of getting a one or getting a two, like two of them, they are not, this one does not depend on this one. So I think the probability might not sum up to a one, that kind of thing.
Okay.
Yeah,
Okay.
let me just add to what he said just now. I want to say the same thing he said, and I think
No.
he said, I think I think what he said is the same thing with what Abdul Shakot was saying, but I'm just saying the same thing. So like he said complementary events is like a special case of mutually exclusive events. So I agree with that because using your example, you first started by asking us what is the sample space and what is so like in a complementary event, the sample space is just two. Like it's either going to rain or it's not going to rain. The sample space is just two for complementary events. For mutually exclusive, the sample space can be broader than that. You know, it can be king or queen. It can be joker too as well. It can be club. It can be so something like that. Exactly what they've all said it. Yeah.
Okay. Yeah. Okay. Okay. Sorry. Can anybody give me another example of a complementary event?
I think, sorry, can I say something about that complementary? Complementary is also like opposite two events that are opposite of each other, that kind of thing.
Okay.
So,
Okay.
so now, let me see.
Give me an example. Give me an example of a complementary event, and another
Apart from
example of a mutually. Apart from rain.
okay, let me see.
It's either they shoot you today or they don't shoot you today.
Yeah. Is it that
You
you
can
are
use
dead or
anything
alive?
now.
Yeah,
Yes,
is it that you
now
are
you
dead
can
or
use
alive?
anything.
Yeah, I think is it that you are dead or alive?
Heads
Is
or
that you are dead
tails?
or alive?
Heads or tails? Heads or tails?
So
Yeah.
complementary of each other, that kind of thing. And then I think if we want to pick, if we want to pick for mutually exclusive, it's almost the same thing. Head or tail. Head or tail can work. You can't have both at the same time. You don't have that for a single
Uh,
coin. No.
I think you're kind of conflicting it right now. Like that head or tail might not be the perfect example for that mutual
Exactly.
Exclusive,
Mutually
exclusive.
right?
Yeah.
exclusive.
Yeah, I think that's
Yes,
dice will
using a
go
die,
better.
a die will be better for
Will
yeah,
go
a die
better, yeah. Like
for
because the probability of selecting a one and probability of selecting a two, do you get they are different. You can still select three, four. Do you get that? Like and like mutual is supposed to be more like a brother kiss.
Yeah.
Okay. Thanks so much, everyone. I really love. You know, like the thing is, before Olufemi even talked about the complementary, you know, like there's already this slide here that's already said, okay, let us talk about the difference between complementary and mutually exclusive events. So the thing, okay, yeah, you guys, I really appreciate the stuff. So okay, let me just say this way. Mutually exclusive,
Are you
like
in the morning or yeah?
this might so, okay, who is, can you please mute yourself? Okay, mutually exclusive events is that okay? The one doesn't like an event occurring doesn't like immediately signify that this one is not occurring. Complementary events. Okay, let me start with complementary events. Complementary events or the sample space is just is either yes or no. Yes or no. Head or tail. Dead or alive. You are present in the core, you are present in the community session, or you are absent. That's what's complementary. It is one or the other. Like one happens does means the other. But when you are talking about mutually exclusive events now, so you are talking about larger sample spaces. You are talking about dice. You are talking about what's the samples. Okay, if you want to roll the dice now, what is the sample space?
6.
6. So if I'm okay, what is the probability of me getting a 1?
That's 1/6.
That is 1/6. So 1/6, but probability of me not getting the probability of me not getting a one, that is like 5/6. But what's complementary event is that okay, they are both like half, like 1/5, 1/5. They are both half half. If the both rain and no rain, they have equal chances of happening. Complementary events. Let me come back to complementary event. What's the probability of rain falling? It is, well, what is the sample space? They have two. Sample space is two, right? Probability of rain falling is what? 1/2. Probability of rain not falling is what? 1/2. They both have equal probability of occurring. So any of them can occur. Probability of head or tail. Both it can either be head or it can be tail. So which is like 1/2, 1/2, which is also both 0.5. But when we are talking about mutually exclusive events now, probability of me getting a one is what? 1/6. Probability of me not getting a one is what? What will be the probability of me not getting a one?
All of that possible. That's 5/6.
That is 5/6. That is not a mutually exclusive event. That's not a complementary event. That is a mutually exclusive event. Complementary events, don't take that. Like once one happen, like it's either this or this. But mutually it is majorly on this, it's and it goes to the sample space. Both scenarios have equal chances of occurring. Both scenarios have equal chances of occurring. But in mutually exclusive events, they don't have equal chances. But it's just that if one happen, the other cannot happen. But they don't have equal chances of occurrence. Does that make sense? Same thing with a pack of card. If I same with a pack of card now, if I am withdraw, if I okay, let's say I have KQG then 1 to 10. What is the probability of in that KQG KQG 1 to 10, 1 through 10? What is the probability of me withdrawing a G? Are we still there? What is the probability of me withdrawing a J in like KQJ 1 through 10? Oluwabumi is silent today. I've not heard her voice since morning.
Sorry,
I
can you come
am there.
again? You
Can't hear
said
you.
Hello.
KQG
I
1 to
think
10.
you said
What is the probability of me withdrawing a J in in KQJ 1 through 10?
1/13 because they are
Yes.
54. Yeah.
It is, yeah, okay, exactly. Okay, they are 54. Even if it's just like 1 to that's 13,
But
but
there
it
are
is 1 over
four.
13.
Yeah, there are four different J's. So
Yeah, 4 over, exactly. Thank you. So that is 1/13, right? That is a mutually exclusive event. Do you get? That is a mutually exclusive event, not a complementary event. Please, do we all do? Is anybody still confused about the mutually exclusive and complementary? If you is anybody still confused? Please let me know if you're still confused. Are we all good?
Yeah, I think we're
Femi,
good. Yeah.
Oluwafemi.
Yeah, I think for now.
But okay, wait, okay, now tell me what you understand by mutually exclusive and complementary. Oluwafemi.
Hello. Sorry, you muted
Yeah,
me?
yeah, yeah. No,
Okay,
I said, okay, yeah, continue.
yeah. So complementary has to do with two values, like two major that's just like the other time we talk about head or tail, but I feel like mutually exclusive events draw from a larger number of
um
Sample space.
occurrence. Yeah, it's a number of
Mhm.
occurrence, but still, they are still like one of them has to happen like at a particular time, right? And that one
Mhm.
happening will not actually give space for another occurrence to happen. So I think that's it.
I hope with this first point of mine, I've been able to like convince you and not confuse you that mutually exclusive events is different from what's the other one? Complementary events. Yeah. So yeah, I guess these are some stuff that we talked about in the previous. So as we said, I think we already did this. Yeah, for a mutually exclusive events now, for mutually exclusive events, if an event is okay, probability of me, okay, if the probability of me withdrawing a exactly. Thanks so much for that. So complementary events are mutually exclusive events, but not vice versa. So mutually exclusive events, they are not complementary. Yeah, but complementary. So don't confuse it. Thanks so much. That's also a point of that truth. Yeah. If the possibility of me withdrawing J in a pack of cards is 1/3, what's the probability of me not withdrawing a J? What would be the probability of me not withdrawing a J?
2/3.
Sorry?
2/3.
Withdrawing a J 1/13.
Okay,
12
1
over
over
13.
12 over 13.
Exactly.
12/13. I thought you said
12/13, not over 13, bro.
no. I thought you said 1/3 instead of 1/13.
Okay.
Yeah, I thought you said 1/3.
Okay.
Yeah.
So that's basically what we're explaining here. Probability of events. Probability E is a probability of the event, and P like complements. E complements is the probability is the complement, which is like the inverse, the opposite of it not occurring. So yeah. So now before we proceed. Sorry, Sergio, is your network better now? Do you want to come up and talk first? Before we proceed? Okay. Let's proceed. Okay. What are mutually exclusive events? I think we already explained this. So non-mutually exclusive events, which we also like. Okay, let me go on. What was that? Okay. This independent event, we can also call it non-mutually exclusive event. You know what? Okay. Um, independence events. So these events. Okay. Whatever. I will clear this up. Okay. This event now. You said that we were talking about this earlier. I think we talked about it. Okay. If I am throwing to explain this to non-mutually exclusive events, if I am throwing 2 coins, what will be as this Do we all did secondary school mathematics now? So what will fall in between these parts? This is what do you call these parts? These parts that collide together.
Intersection.
Intersection.
Exactly. So now what will we have at the intersection here? For two, if I was spinning two coins.
Both are head or both are tail.
Good. So good. That good. So there also both are head and both are tail. So that's what we'll have here. But when they are different, we'll have so non-mutually exclusive events as we already said, independent events. So but I think we already explained that. So conditional probabilities. Conditional probabilities. So okay. For events E and F, the conditional probability of E given that F has occurred is denoted by probability of E given F, and is defined by this formula. Then we say that the events E and F are independent. And when we say they are independent, what do they mean? They are non-mutually exclusive. Okay. So I think we already explained this particular stuff. This is just the note. So conditional probability. Wait, so what am I saying? As occurred is so probability of E given F is the probability of E and F occurring together over probability of F. Okay, let's do this quick. Let's also do this quick. Let's do this quick. Okay, I think I already. What's the answer to question one? What's the answer to question two? What's the answer to question three? What's the answer to question four? Whichever one you are answering, or mute yourself and let us know.
For question one, the answer is half.
Yeah, I think I already answered that earlier. For question two, if you watch the video, you should know the question. You should know the answer to question two.
Question two is 17.52. Question two is zero. Question two is zero.
Any contradicting answer? Anybody wants to prove him right or prove him wrong?
Question three is 3/4.
Question four?
Question four is 3/7. Abi? Yeah. No, sorry. Is it 3/7 or 7/3? Wait, chill. I'm sorry. Let me.
It can't be 7/3. 3/7, I think.
3/7. Yeah, yeah, my bad. 3/7. Yeah,
So
yeah. I was twisting.
Does anybody have any contradicting answer? Is anything like unclear to anybody? Okay, can anybody else tell? Okay, you just give us the answer. Now somebody else should give us why the answer is that. Okay.
I think the last this is the last question you're asking now, but I think if you go back to your slides, just the slide that you showed us before this one, I think the last question applies with that formula. That's the conditional one. I think so.
Okay. All
Yeah.
right. Okay, but okay. All right, thank you very much. What about the other answers? The other answers. Anybody
So the
wants
first
to
one, okay, the first one, multiple of two, like I think you explained it already before. So 2, 4, 6. Then the probability of an impossible event, that's of something not happen, that's zero, like he said. Then the two unbiased coins are tossed, probability of getting at least a head. So meaning you can get one head, and you can have two heads. So that's the total sample space should be 4. So meaning that the only one that is likely not to occur is getting a tail. So that's 3/4, which is 0.75.
Okay, thank you very much, everybody, for your contribution. So now our time is fast spent, but I'll breeze through. I'll breeze through. I'll breeze through and see before we
Yeah,
go
yeah,
into.
because I have a question about the distribution. Like that's why I'm in class today. I have a question about the
Okay.
distribution. So when we get to the end, yeah.
Okay. So a random variable. Okay, a variable. So a discrete random variable, continuous random variable. So a discrete random variable, okay, that's just like, okay, let's just call it something. You can just call it like, okay, maybe like 1, 2, 3, 4, 5. Continuous random variable, we can call it like 1.0, 1.10, 1.12. From 1 to okay, if you are counting, if you want to count decimals from 0 to 1, you can have as many numbers between them. You can have as many numbers between them. So do we get, so that's the difference between what's it called? So I want to drop the attendance link. Okay, I will drop. Okay, so that's the attendance one. So that's those are the various kind of okay. So if you are so that's the continuous random variable from 0, so from between 0 and 1, you can have as many possible combinations. You can have 0.001, 0.0015, and like that till you get one. They are uncountable. So if they ask you, so this is, so as a advanced student now, after 0, what is next? It might not necessarily be 1, depending on the context. Is it 0.1? Is it 0.5? Is it 0.01? 0.0001? So that is in continuous variable. So the values are, it can be as massive as possible. But if you're talking about discrete random, that is when we know that after 0, we have 1. Does that make any sense? I hope so. So yeah, this is also when we're talking about the probability mass function. So remember, the sum of all probability is always equal to 1. The sum of all probability is equal to 1. If the sum of if the sum of all possible occurrence is not equal to 1 in your probability, then something is wrong somewhere in your calculation. Go and investigate it. Sum of all possible. If I'm saying that, let's assume, the possibility of withdrawing a J and the probability of withdrawing a K. I mean, we're withdrawing a J and the probability of not withdrawing a J. Do you get? So that is 1/13 plus 12/13. That will give me 1. So that is, and this is so variance, standard deviation, and yeah, this is a place where we use distribution. So now this is now common the distributions that we use with this probability mass function. So the Bernoulli distribution, that is just okay. Yes or no? So we can say that, oh, it's just similar to our what complementary. Blah, blah, blah. I'm not saying it's complementary. But it's a single trial with 2 outcomes, head or tail. So that binomial, the number of successes in a fixed number of independent trial. Okay, let's say I flipped. Okay, as I said, the example I gave you, I flipped the coin 10 times. How many heads do I? Okay, I'm trying to understand. Okay, now I'm concerned about the heads. So how many heads do I get? How many heads do I get within that particular time? So that's an example of binomial. And then Poisson, okay. Now it deals with the number of occurrence within a specific time interval. Number of occurrence of an event, number of events within a fixed interval. That is Poisson. Now, probability density. Um, okay. Is which one do you which one were you confused about?
Yeah, sorry, my bad. um, so it's not really confusion. Like I just wanted to get some. I wanted to ask some questions about it because I was following her in the video. It was very interesting. So, for example, now because like I want my own is what I like the theory, but I want to know how I can use this like when we are doing our
Oh,
projects and
oh okay, 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 okay. Oh,
so
okay.
so like in a classification problem like cancer, like we're trying to predict cancer and we have a target variable. Now the target
Mm.
variable will either be zeros or ones, that's cancer or no cancer. So that target variable now, is it supposed to like what distribution is it? Is it a Bernoulli distribution or is it a binomial distribution? Like
Okay. So okay, when you are building a model now. I think okay, Sergio can also talk about this, but I will just give this. She can just okay. In a Bernoulli in a okay, when you are building a machine learning model, there are some assumptions that your algorithm like that's they make. So and for you to get the best of your algorithms, for you to best of an algorithm, your model as your algorithm, they assume a normal distribution. Do I have a let me check here. Mhm. Do I have a normal distribution here? Okay, let me okay. So okay. So this is where when you are doing all those this is when you are building your model. Most of the assume like you have your data as a standard as a normal distribution. But it's not always that way. When you read more of the theory, when you read more of the theory of the models, what they expect, you understand this better. This is the is a bell shape. So and this is what we call Gaussian distribution. This is what we call a Gaussian distribution, which Teju was explaining in our lecture. So this is a standard this is a normal distribution, which is also a Gaussian distribution. So it is one of the most important distribution in machine learning, and most of your algorithm, as they assume your model come with this. But what if your model doesn't have this kind of normal distribution? Then the assumption that is made for you to make some calculations, it will be wrong. So like the mean, the standard deviation, it won't be able to like properly calculate it. And also if the range of your feature now is very wide, it's like it would struggle to scale. It might struggle to scale, especially if you're talking about linear regression. Even though some tree based model can work with it perfectly fine, but if you are working with linear regression, it can struggle to converge. So so in that case, what do we do? If you have features like that, probably numerical features, probably left skewed or they are right skewed, what do? You now convert them to a normal distribution, which will help your model to converge better. Does that make any sense?
Yeah, it makes sense that it will help the model to converge better. That makes better
Eh,
sense. Faster, safe,
Exactly.
even faster.
Exactly.
So
Better, faster.
so now with what you said now, I'm just linking it to the what you was teaching, the theory. Now,
Okay.
it's better to it's better that they are in this in this shape or distribution, because the models assume that they are in this shape or like distribution. So I was asking something now. Now you're doing a, it doesn't even matter whether it's regression or classification, but let's just say linear regression. Let's say, yeah, let's focus on linear regression, and linear regression to be specific, not just regression but linear regression, because linear regression assumes that it assumes that the data, like the distributions should be normal. Now
Mm-hmm.
you have numeric variables, like your data set has 25 features, and
Mm-hmm.
about 20 of them are numeric. Now, yes,
Mm-hmm.
obviously when it is random one way or the other, at least if it's random with that number of features, at least one should be normal possibly. But let's just assume that, okay, as worst case just one or none is even normal. The remaining 20 or 19, what are you supposed to normalize them, like, transform them using any of those transformers, like standard scalar or max min max, whatever? Are you supposed to normalize them, all of them? I'm not talking of one, all of them, because I want a template that I'm asking you so that I can use this as a template in doing everything, including our current project and every other time I'm building models. How do we handle all the numeric variables? Is it just some that we can, because sometimes we only do this for some of them, not the other columns or the other features. Do we normalize all of them? And what's because now the numeric variables will be what you just showed us now, the random continuous variables. So then what treatment do we give to discrete variables after we do like maybe label and coding, like, and stuff like that? What treatment can we give to them in light of these assumptions that the models give, for the data sets? Yeah, that's just basically it. Thank you.
Yeah. There was a link I shared. Okay, I don't know if it is. Okay, no, no, no.
Yeah, is it the link on the normalization? Yeah, I have it.
Yeah,
I
yeah.
a book,
Okay,
not it.
can you quickly share? Can you share it? Can you just share
Yeah,
it? Okay.
yeah, I'll do that.
But
Yeah, but that's my problem.
yeah,
See, the article, it does the same thing that everybody does. Everybody just tells you what it is, but they're not telling you how I will use it in Jupyter Notebook. Like, I just want to
do you
know.
mean the code? Do you mean the
No,
code?
not the code, not the code. I want to
Okay.
know, do I have to normalize all the numeric variables to, must all the numeric variables be of normal distribution before I train
Okay.
my model on it? That's what I want to know, because that article doesn't say it. YouTube videos
Okay.
don't say it. So that's why I just want to know.
Okay.
Yeah. Yeah.
Okay. Yeah. The thing is, if you are first of all, your numeric variable, if a particular color is having a discrete value, look into it at first. Okay, this discrete value now. Okay, let's say, is there a level of I said, is there a level of what's it called, hierarchy, or is there a level of hierarchy that is present in that particular feature that you don't want, that you need to be preserved. If there's a level of hierarchy, then you can leave it as 1, 2, 3, 4, 5, 6. Because if you are doing it that way, if you are labeled encoding, you should just like leave it that way. So why everybody will not just tell you that this is what you should do and this is what you should not do, is because everything all depends on your data. That's where exploratory data analysis come in. When you plot this histogram and you see how your data is performing. So when you have a, especially features that have large numbers. Let's say you are talking about price now. price can go from anything between, let's say you are doing house price now. House price can go from anything from 50,000 to maybe like, let's say $50,000 to millions of dollars. The range is very wide. So it is important that you scale it. If you are doing min max scaling, okay, probably you want to make your data between 0 and 1. You want it that way, or it's also a means of normalization as well. There is min max scaling, there is zero normalization. It depends on your data. But I think you should always scale your data, but that is continuous. For discrete values now, you can treat them. Sometimes you might treat them as, just like label and code, or sometimes you can decide to treat them as a what's it called, as a one not encode. Okay, you want to determine the price of a car now. I mean, the price of a car, and then there's a feature that's called the how many liter of fuel that the car can carry. The number of fuel, can it affect the price of a car? The amount of fuel a car can hold at a time. Do you think it affects the price of a car?
Yeah, yeah. The size of the tank, the
The
size
size
of the
of the tank.
yeah.
Mm,
Yes, it does. Like, cars of two
okay.
the same model, but it's more tank. One with the more tank should cost more.
Eh. So if you feel like, so once you feel like the higher the tank, then the higher the price, then you can leave it as a label encode. You can just leave it as, okay, 1, 2, 3, like that in a column. But if you feel like the size of the tank does not affect the price, instead of leaving it as a number, you can decide to leave it to instead of leaving it as a label encode, you can use it as a one-hot encode.
Okay, yeah, yeah. I mean, I grab everything, right? It makes so much sense. But why I want to know is because the both the scalars that you spoke of and all of that, like, yes, they both change. They both make your data sets a normal distribution. Both standard scalar and min max, they
So
Mhm.
they make it,
can I can I
standard distribution.
can I quickly come in, Uzondo?
Okay, yeah, sure,
Um,
sure.
yeah, so actually, like, when you scale your data set, it does not change the distribution, so to say. Like, if you if you have a range that is large and you do min max scaling on everything, you're just changing the range of that. If the distribution itself, it still follows that like what it is. So if it's not a normal distribution, if you do min max scaling, it will not automatically change to a normal distribution.
Mm.
At least this is my understanding. So, like, I just don't want us to conflict this. So there is this Gaussian assumption that is made by all like most machine learning model to make it easier for modeling, because Gaussian has really nice property. It helps us to be able to like quickly find the we can do maximum likelihood estimation because we can find the maximum of that likelihood. If you look at the video that I made, you would get a better understanding of what I mean by that, because I explain it there. So, but your question is that what in practice, what should you do? And what most people do in practice is that if you have a data set, let's say you're talking about a tabular data with numeric and categorical columns, and what you would want to do is if like you always want to scale or standardize, so to say, not just scale your numerical column. And the reason for doing standardization is not to shift the distribution in the way I think you explain it right now. It's more like to make sure that all your numerical columns like you don't have large value, like let's say one column has a very large range, and the other column has small range, it might affect like the algorithm in modeling because of you're learning different weights for the different features. So you want to make sure that they are all like nicely scaled in the same range, such that when, let's say, you're doing something like uh, back propagating, you have gradients. It's not too large and it's not exploding. I know I'm starting to use different terminologies, but so I think most of these terminologies you've heard of in the past classes. But just to come back here, you said, then what do you do? Okay, let's say you've agreed that it's a good practice for you to normalize or to standardize your numerical column. Then your categorical column, what do you do about it? And I believe that this was also covered some weeks ago when we were talking about one hot encoding and level encoding as a way for you to handle your categorical column. So I think the confusion, if I'm understanding your question right, is like when you looked at this lecture on probabilistic modeling, we were talking about like how you need to know the distribution in which your data come from and how it's important for the machine learning algorithm. So, and you're like, okay, so what do you do? Should you change your categorical data to Gaussian? It does not follow Gaussian. It's not a continuous data. But if you want to stay in that line of thought, which is exactly what the lecture 2 on naive Bayes and MLE try to explore, whereby in the at the last part of the class, I looked at a data set of spam or no spam in order to do classification task. And in each of the features, each of the columns rather, they were modeled differently. Actually, at the end of the day, we used one distribution to model them all, and it was Bernoulli. And it was because we looked at the data, the way we expressed the features was in the form of 1 or 0s. And we were like, okay, what kind of algorithm works in this way, in which you can have a probability of 1 or probability of 0? And and this is why Bernoulli was like a really good distribution to model this data. And if you look at your categorical column, this is essentially what you would end up doing, because they're like 1s or 0, right? When you have like one hot encoding, for example. Here we didn't do anything like we didn't use the Gaussian assumption. We didn't model each of the column as Gaussian because the features were not expressed in a continuous manner. But if you wanted to take it one step further to challenge your understanding of the material, I would encourage you to try to take a data set that is continuous in nature and apply naive Bayes this like on that. So I think it's so in SQLN, I also showed that you can use the Bernoulli naive Bayes package to achieve the same thing that we did together in class. But you can also look at, I think there's Gaussian naive Bayes, if I'm not wrong right now, and you can try to. So, but that is, you would, if you look into the implementation, you would, or like at the explanation, I'm almost certain that it's used for like numerical, like if you're trying to do like continuous feature modeling. So you could try that out. It's a way for you to really solidify what you're learning. But I hope this has provided a little bit of guidance, but to just give you like to say what you should do, because this was the question, like you have a project, you have a data set, what should you do? Should you process your data, or do you need to like now transform everything to like to be Gaussian?
Yeah, so let me like, so maybe I get the part of the scaling. I think I should have said scaling, right? So what I want to know is this, like in light of I'll still go and watch the maximum likelihood video and learn more, but from the distribution video, and so from what I've seen from research and all of that, it's like the linear regression, for example, I'm using linear regression as an example. It assumes that your data should be normal distribution, right? I mean, I don't know if I'm wrong. You can correct me if I'm wrong, but it assumes that the data should be in like a normal distribution. So I understand scaling, and maybe yeah, min max scaler doesn't do that. I understand scaling, but what I want to know is that if you plot your, like if you do your EDA, when you do your EDA and you plot histograms and all of that, and you see that your numeric, or you do pair plots, and you see that your numerical or your numeric features, they don't have they are well scaled. Let's assume that they are well scaled, but they don't have like a normal distribution. Is it okay? Like, does it affect the model if you can apply a transformation to make it normal distribution, or that is the, or you're not meant to shape, like you said, shift the shape,
No, no, no. Yeah, so the
or
thing
I'm
is that you can try
misinterpreting it?
to. You're not missing. I think you're really understanding this, and it's good that you're asking questions to clarify. Because when you like what you're trying to do, like you have your data set and you found out that it's not Gaussian, so this assumption is not going to work very well, right? Like you have a data set is skewed, and what should you do? Should you just give up, or like you still want to use this algorithm? And what in practice a lot of people do sometimes is that they try to apply some transformation to rescale the data in such a way that when you apply the algorithm to it, it works. I'll give you an example. So there is a project I worked on, or there's like for synthetic tabular data generation, and one of the key innovations for that paper I took again was in their pre-processing. So they were working on the tabular data set, and they knew that with the way the data sets sometimes are constructed, they don't follow the Gaussian distribution, and this is one of the important assumptions for GANs. So what they did in in pre-processing of the data, they add this clever they call it was it uh, uh, it's not mode what's it called? Is it mode specific normalization? I think that's what it's called. And and then they apply some Bayesian Gaussian mixture model to to transform the input data to a space where it is Gaussian, and then apply GAN on it. And after they apply GAN on it and they learn the joint distribution, then when they did the inverse of that process in order to get back to the original data. Do you understand what I mean?
Yeah, I'm
So
following.
so that what you're saying makes sense. Like you have the data and you see that it's not following the normal distribution, and the assumption may really like you can apply the algorithm. It might work to some extent, but maybe not maybe you wouldn't get the best result out of it because the assumptions are not held. So what would you do? You would start to think about ways in which you can manipulate your input space to be able to make sure that you when you apply the algorithm based on your knowledge of the theory of how it should work, you're able to get it to work.
So basically, it's still just like experimenting, trial and error. Try this,
Mhm.
try that.
Mhm. Mhm.
The only one reason why I'm asking this is because the session where we spoke of normalization, the link that Yomi first sent to us, he did in the sample when he was showing us the Jupyter notebook, the collab notebook, and all of that. We looked at a feature, one of them, and it had a weird shape, the distribution, and then Yomife applied log scaling to it, right? He did log transformation on it, and after he did log transformation on it, they were rescaled. The scale changed, right? It shifted, it shrunk, right? But at the same time, it's the shape changed to a normal, like a bell curve. So
See,
I just
that is
wanted to
great.
know,
Now,
yeah,
now it's able to apply. Now you're able to run the algorithm because now you've like really like you've changed you've tried to make it normal in a way
yeah.
to
So now,
yeah.
what I'm asking is that should we do that for all the other features to make them normal before we train them? Like he said something about making the model converge faster, right? So should we do that to all the numeric columns, that transformation to make them? That's for numeric columns that don't have that shape. Do we have to make them like that? Hello.
Yeah, yeah, you there?
Okay, I
Yeah,
think she's saying, yeah,
yeah.
I think she's saying, yeah. Okay, so we
Yeah.
should do that for all of them. Okay, fine, fine. Thanks. I just wanted to, that's what I wanted to find out. So that I can start doing this now because it matters if I want to do a machine learning competition or something like that, right? It will
Okay.
matter. I'm just saying. So yeah, thanks for that. Thanks so much.
No problem. Thanks so much for the questions. Our time is fast spent. So just as we do so, so I hope we've all like enjoyed the class and learned something or two from the class today. Okay, let's just okay. Okay, there are some announcements that will be um for any others. There's some announcements that I want to like pass across to everyone. So, yeah, kudos to everyone that participated in project proposal submission. But let us, if your team member is not active, you can let us know. You don't necessarily have to put that person in your project, but please, that doesn't mean you should not carry everybody along. Please carry everybody along and try as possible to reach out to people you feel like if you see they are not contributing as they are supposed to. So yeah. So during the week, we'll be reaching out to teams. So we won't just be meeting with the team leader, we'll be meeting with like the team as well, and then fleshing out how the project is going to proceed with everybody. So yeah, that we'll communicate that during the week. And then hopefully by next week, by next community session, Mr. Femi and Sis will be available to take the model deployment class. So everybody will be able to deploy their project on whichever platform of choice after the class tomorrow. I mean after the class next week. Yeah, so as from tomorrow we are going into week 9 and then we'll be going to supervisory and recommendation system. I saw that a team. What happened is my after tomorrow we're going to also advise the recommendation systems. So I saw that there was a team that wanted to do recommendation system. So yeah, in terms of rooting for you guys. But everybody doesn't because you are doing a group project doesn't also mean you can't also like do other ones by the side as well. If you are working on any projects and you need any probably you are confused at some points and you need any guidance, feel free to reach out on the Discord channel and we'll get back to you. So unsupervised learning and we're bringing back assessments this week. There will be an assessment this week, and the assessment will be, you'll be the bureau recommendation system. So probably either music, movie, whichever, probably products, whatever. We'll be building a recommendation system this week. Or you can okay, it might be a recommendation system, or it can just be a clustering. Just do something around unsupervised learning and recommendation system. Recommendation system is a form of unsupervised learning. So yeah, so just build something around it. Let us build something around it and submit it. There's no explore. All I said, yeah. So that will be it for the coming week. And please, everybody, let us. You see, all this theory that we are talking about. These are stuff that will guide how you approach your machine learning model. It's not just about importing a library and implementing and just implementing a library. Everything you are doing will. All this story will guide how you actually utilize each of these libraries. If it's easy to just import them, but do you understand what is going on? Do you understand why you are using it? So please let us go. Don't worry, those of you that still have assessments, yeah, Yeah, so Tej, do you have anything else to say to everyone before we drop off the call?
No, I'm afraid it's all good for me. Thank you so much, and have a good weekend, everyone.
Yeah, okay, all right. So please,
Yeah,
thank you.
sorry. I just wanted to, at the beginning of the class, I was the one that I asked about the whether that week 7 assessment, that was a non-linear course. I had
Okay,
like
okay.
some, yeah. I just wanted to know
Yeah,
whether it's still possible, yeah, to submit.
yeah, submit
Okay,
it.
thank you. Thank you very much.
Okay. Yes, Olabumi.
Hi, Yamife. Hi,
Hi, Olabumi.
everyone. I just want us to take a moment to appreciate Yomife. Yomife has been so consistent. I know we are going into week 9, so we have like 16 people on this call, maybe 14 of us, excluding Teju and Yomife. Can we just say thank you, Yomife? It takes a lot. He's been there for us. Sincerely, Yomife is doing so well. Please, I want you to clap your hands, put it into the comments. And he's not asking for this. So, I was just thinking in my head this morning, I'm like, Yomife has been so consistent. Yomife has been so patient. You know, you might not think him of the best teacher, but I tell you that he is definitely going to be the
He's the
best,
best teacher.
right?
He's the
So
best.
thank you, Yomife.
Guy,
Thank you
you
very
cannot
much.
thank Yomife enough.
Thank
He's
Sincerely,
you.
the
you
best.
cannot thank
Thank
him
you.
He's the
sincerely.
best.
Thank
You are the best. Boss, you are the best.
Honestly,
Boss.
thank
Ah,
you
honestly,
very
Thank
much.
you're my daddy, like in this thing.
I beg.
Boss. Ah, guy.
I
I swear,
thank you so
don't
much,
leave me.
Yomife,
Please don't leave
for
me.
you.
Uh,
Thank you so
thank you
much.
very
Thank
much.
you so
Thank you
much.
very much. Thank you very
So
much, everyone.
we really appreciate you. We really appreciate Tejumade to we really appreciate our
Yes, we appreciate
so,
you. Thank
Mhm.
you.
thank you so
Thank
much. Thank you
Yeah.
guys for
Ted, you
everything.
are awesome.
All of you make
Yes,
me
for
all of
sure.
you make me
Thanks, Teju. Thank you so much.
I
Always
don't
there.
think I don't think
Thank
Teju
you.
I don't think Teju is
I
here again. I think
I
she
have a
left already,
convention, please,
so she can't
guys. I
she
have a
can't stay.
convention.
Okay.
So here's the thing. Actually, with the little knowledge that I acquire from you guys, so I took a bold step to apply for an internship, and the man did interview for me twice. I had the last one on Friday. It was crazy. Like all the questions, everything he was just asking me was like what you guys have treated with us in the video and everything. Even I shared my repo.
uh,
Okay, you guys,
uh,
I will get back to your stuff. So I really thank you guys for what you've done. So I can't thank you enough. Thank you so much.
yeah, so thanks so
Yeah,
much.
I
Thanks
also
so much for
yeah,
the
Man, you
and
have to pay your tithe to
all these
Nana, pay tithe.
assessments,
You have to pay tithe.
yeah,
Oh.
and I also want to appreciate
I've
them
not been
for
employed. I'm still on view.
No
yeah, I also
problem.
want to
By faith,
appreciate
we
them
have
for
gotten the
this.
job already. Say man.
Amen. Thank you.
Good
You
luck.
know what I mean?
Yes.
Yeah, me say, yeah. So
Thanks.
I also want to appreciate you guys for more especially the assessment because I feel this assessment, no matter how hard it is, like it can be, that is always it has always been like a good push for us to like at least get hands on with this AI Saturdays Lagos, and it's also trying to help people to build their portfolio like on their GitHub, that kind of thing. So I'm really appreciative for like this particular process, like what you guys have been helping us with and stuff. And you've always been free flowing, especially on Discord, that kind of thing. Even flexible with the submission process and things like that. So, like, you guys have really done a lot for us.
Thank you. Thank you very much, everyone. I really appreciate you guys. Thanks so much. It's a pleasure. It's an honor to be before you guys.
I said
I do
you are not
say
emotional.
sorry.
I said you are not emotional.
I am actually. I don't. This I never thought I never saw myself like I didn't even know I would like teach a course or something like that. No, but it just, I met Teju and one discussion led to the other. Will you be able to do this? So this supposed to, this was, I don't know if you guys were here at the beginning. This was supposed to be like a quote. It was supposed to be like, me managing, like, people that enter the community and, guiding them based on like on machine learning. If they have questions, I'll be the go-to person. And if there are questions that I can't answer, then I push it up, and
Was
then
that why you
Teju
guys called
answer.
it flipped? Was that why you guys called it
Yeah.
flipped?
No, the reason why we flip, we are not like the videos we are using is from course 8. So the idea was just like, okay, or when people come in and they need materials, I just like send them the materials, and the way the materials were taught, they were very like, they went deep, not just for the surface level, not the surface level machine learning that everybody just out there. They broke it down. So it's like, okay, suggest it and then watch the stuff. If you have questions, ask me. But when I started, and people didn't have like enough ginger to answer. So after sending it to them, and then maybe after few days, it's just that this person is no longer responding. What, and reach out, can you come? So like, okay. So I then suggested that, okay, probably we should have like a flipped quote. So it's not like an inverted learning. So is if you search for the meaning of a flipped classroom, that this is basically what it is. So there's already a pre-recorded videos. We send it out to you guys. You guys watch it. So when we are coming here, we're not just coming to teach. We're just coming to like discuss and engage with each other. So and I just suggested it, and just said, okay, will I be able to like lead the course? And okay, let's do it. And seeing people like committed to the process makes the efforts that we put into this worth it. Even though where we started, we had a larger number, but people will always get bored, get tired, and fall off around. Blah, blah, blah. Seeing people like still committed to it, it really warms my heart. And thanks so much, everyone. I really do appreciate you guys for sticking with this course. It means a lot. It just means that, okay, whatever we are doing, at least some people see that we are doing like something right. So we're not doing all that bad. This is my first time teaching a course, so I know I might not be the best teacher, but I promise I'll try the best I can. And I welcome every feedback. I welcome every criticism. Thank you so much, everybody. I really appreciate it. And
You are
You're
thanks
better than
welcome.
for
you are better than all the data science teachers on YouTube. All of them.
You're
yeah,
welcome. Thank you so
and thanks to Teju and the AI Saturday community. This community has been since, I think, it was not 2017 or 2018, and it has been built over time, and the quality has been there. So leveraging on level. So, and me just coming here is not just me. Before we started this stuff, we had a lot of conversations with the team. There are people that don't really necessarily come every week, but there's nothing that's happening here that they are not aware of. So yeah, they are the OGs. They are the OGs, the people that they are the Igileyan. How do I say it now? How do I say that in English? They are the pillar behind this community. And you guys too are also the pillar, because you guys are also what is a community without members? What is a community without people benefiting from it? So, and I'm glad that you guys have found this word. And yeah. So, but please, regardless, just it will be a nice experience for us, for everybody, when we see you guys, doing hard things, trying hard things, and working, building on top of what you have learned here. We cannot explain everything to you. And you see, we weren't able to complete the lectures. But the part that we were able to touch, I tried to, as much as possible, to ensure that we understood it. So please go through these thoughts, and if you have further questions, reach out, let us know. We are here for you. um Build other projects aside. So that's what I'm saying. Even aside the unsupervised learning assessment, do this assessment, do it like you are building you are building your own repository. You are building your own profile, so that if you are going for an interview, okay, probably in an organization they are doing what they are doing, what the major in is unsupervised learning. Okay, the first thing they will ask you is, have you worked on unsupervised learning before? You say yes. What's the evidence? You show them. So don't just do the assessment because they are asking you to do it. Do it because you actually want to learn it. If you do it and then you understand it, if there are things you don't understand, you ask questions and then you do it. So even the previous assessments that I have been doing, probably after week 10, after we submit the assessment for week 10, even before the end of the course, or even after safe, even
Will
after the
you
course
open
ends,
it,
we can.
Yomife? Will you open
It's not just
previous assignment?
okay. I don't know if I should say this on the call, but I've
Please
not closed any
do.
of the
Please do.
assessments.
Please
Please,
do.
there are some of us that have
Please,
not
I have never,
yet,
I
Yomife,
you
have
even
never,
for
it's in
president.
help
Yomife,
this
us.
please.
is true. What you guys do, if you guys had checked, you see that no, I have not closed any of the assessments. The only assessment that was closed
Whoa!
was the week one, which
Yomife,
was
are
was
you
which was
serious? You are real MVP.
I did close any, but because you
Yeah.
guys did not check, I also did not see anything about it. If you guys
Wow.
had checked, you
We
guys would
thought
have
you have
seen that.
closed. No, thank
So I
you.
So,
haven't closed it.
so bro, I've been begging for assessment this thing for nothing.
I haven't closed any, but please, but when we will close it, we'll close it. I'm just when we'll close it, but we haven't closed it. But
Don't close
please,
yet.
please,
Let me finish my own pending assignment.
But
and please,
Yomife, sorry, I
yes.
just want to ask. I just want to ask regarding this assessment stuff. Like, do we need to, like, at the end, does everyone need to like have done all the assessments, or just like it has to be like maybe a benchmark for getting, just like when you were trying to point out the certification process?
Yeah.
I don't know if you get my question.
Yeah, look, can you see this GitHub page on my screen? So 40% average assessment score, and also like 40. So the thing is, like you must have 40% average assessment score, and you must participate in like 40% of the assessments that we sent out. But much more than that, much more than the assessment, much more than what we tell you to do the assessment. It's more about you building your portfolio. You see, that's the reason why we're telling you guys to push it to your GitHub. If you guys, so after whenever you are whatever all those stuff that are on your GitHub, you actually did it. You did it by yourself. So I want you to be able to say that whenever you are pushing this, whenever you are sending this to an employer, you should be able to like defend it and be proud of whatever you did. Don't just do it for submission's sake. Do it for the sake of I want to know it. Most interviews they won't just ask you, okay, anybody can import library, anybody can, do log transformation, but you should understand, why am I doing, yeah, at this point, why am I doing log transformation? At this point, why am I using this particular model? Why am I doing this? Why am I doing that? These are questions that will come up in interviews. It is our joy when we see you guys, when we see you guys, doing great things and being in big organizations. Right now, the Mr. Femi that is coming to take deployments next week. He has done his masters in AI. I think he completed maybe like 2 3 years ago. He's a chief data science. He's a principal data scientist at this company. There are a lot of people. There are people that are doing their PhD in US, in Canada, like that, and that finished from this particular community. So there's a lot of opportunity in you like knowing all these things. There are people there was even I was at one person, I don't know, there's one community machine learning because they deal more in AI. They don't do more of this machine learning stuff. So it's not a boost, they don't do boost, they just do like community sessions. So there was I attended one of their community sessions, and one of the speakers is a senior data scientist. Where did he said during his talk, he said he started his research experience from AI Saturday Lagos, and he went on to do his masters in the US. In the US, I think it was in Texas, and then he was also he has his own community as well, and he was also working as a senior data scientist or what. I've forgotten the name of the company. But what I just want us to know that there is a goal behind persevering and understanding these things. You should stand out, not just okay, we are just like using like importing this library, importing this library. Everybody can import the library, but do you know why you are importing library? Do you know what the library is doing? So, and I like that about us that we are not just like going with everybody. Though it is good to know it at the surface level, but it is even much more better. You are going for interviews to understand it at the surface, or at the like under surface level. So kudos to you guys. Thanks so much for sticking with us. And you can build other stuff, during the time where we'll be doing there will be a 3 week gap after week 10 lecture before you guys present your projects. It's supposed to be October 18th, but some people said they are going for Data Fest on October 18th. So that's why I said, okay, instead of October 18th, let us move it to October 25th. So during those time, even when you are done with your projects, do other stuff. Work on different projects. Look at data sets. What are the stuff you're interested in? If probably you do something for your assessments, you can work on something similar again, not just that same data set. Work on something similar again. Try different things and see how it works. The more you do these things, the better you become. And we are looking forward to everybody being in greater heights. And don't worry, we are rooting for everyone. And please keep the channel, keep it active. You guys don't talk on this channel. What should we do? How can we solve that?
Yomife, I also wanted to talk about some people like this project stuff. Some of these team members are not really responsive. Like it has been a problem trying to even reach out to some people. Like they indicated interest to join itself, but during the whole project proposal process, because everyone has like conflicting schedule times, so to get everybody now, and sometimes they don't just respond. And just like in my group now, I've hinted on, at least even if you can't um talk about, like, even if you can't contribute at that particular time, you can just communicate like prior, like just let everybody know that okay, I won't be available for this. But some people they don't just communicate at all. So that's actually been a problem in my own group, personally speaking.
Okay.
Sorry,
At the same,
sorry,
I
Chitom,
don't.
Chitom, you have a group. Chitom, are you in a group, Chitom?
I'm in a group.
Or are you guys already like complete?
We are not complete. We are not complete. And just like I'm saying, like we have passive people. Do you get? And I don't want to meet normally. Like we are all strangers at the end of the day because we just met through this online platform. So I'm not one to be like texting you as if I'm like you're owing me money. You understand? Like, because I
Yeah,
think I've
sure,
already
sure, sure.
hinted enough about communication, like communicating. Like, do you get? Like that's the least. That should be the least. Like you just at least show like some efforts that okay, I won't be available for this, that kind of thing. But some people they don't just want to keep up at all, that kind of thing. And at the end of the day, I just feel I think in my own group it's just one person that has really been responsive. I can't even lie about it. You get?
Wow. And
So
how many are in your team?
we are like three or four. We were four before, but one person, I think that one has even left because he hasn't said anything like for like 2 weeks at all. You get? So I don't really know. I'm tagging on Discord, so it's not like they even engage like that on the Discord channel. So that's also a problem.
Ah, this is I don't. You know what? Talk about it on the Discord channel.
Izu,
I will talk
Izu,
with
are you on a group?
talk.
Yeah. I'm in a group and we are actually full, yeah. But I was like in the following weeks, I might have some time. So I was thinking maybe while me and my team will have done our stuff, I could just because actually in light of what Ife is saying about doing projects, I might have some time in the following 2 weeks. So I
I
was
think I
thinking
wanna
that maybe
okay
I can
to
just
share again.
yeah, just jump on a call with you and do like that's
Yeah, no
my me and my
problem.
team. Don't worry, I was sorted, but I can collab with you too and do something.
No problem, no problem. Well,
Okay.
Yeah. So,
I
so
can
what's
reach
your
I can reach
Discord
out
name?
to you okay. I'll
Yeah,
just
yeah,
type it to you.
I'm active on Discord. Yeah, yeah. You can
I'll
send me
I'll
your Discord name or yeah, you see me. I'm the guy that reacted to Yemife's the last post that Yemife just made
I think he
on.
even reacted to one of my messages on the Discord when I was trying to
Yeah,
beg him to extend the submission
yeah,
to the assessment.
yeah. Exactly. Yeah, that was it.
No
Yeah, that
problem.
was it. So just
I'll
reach out to
DM
me.
you there.
Yeah,
Uh,
yeah, okay.
Okay.
So that we can. I'm sure you guys will be able to do something before next week ends.
No
And say,
problem.
yeah.
So
Uh,
if if whatever you guys work on, if you want to, you might also present it like differently as well. Like aside the one you are already doing with yourself, you can also like present it and let us know whatever if you whatever when you flesh things out, you can let us know and however we can help you guys, we'll be there to help you guys. Is that okay? Is that okay?
yeah, by chance, I wanted to ask about the deployments that will be happening in the deployment class. Like, do you have an idea of what we are covering in deployment? Like, are we doing like Streamlit or Flask, and are we like deploying to production or just putting it in an app or an API?
I think it's an app I think we'll be trying Hugging Face Spaces. I think you. I'm not sure if we'll be trying Spring. Is it? I'm not the one taking the class, so I
Yeah,
don't
yeah,
really
yeah,
know.
yeah, 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 yeah.
But don't
That's
worry.
yeah.
You can whatever whichever one it teaches you. You shouldn't. That doesn't mean you can't like try out any other ones. Do you get
Yeah,
so?
no. I just wanted to know. That's why it doesn't really matter. Just curiosity. That's all. Thanks.
No problem. All right. Non see. Sorry for keeping waiting. Yeah, you can go ahead.
Izu, I just texted you on Discord now, so
Hello everyone. Okay,
Hi.
for the whole project something, I was meant to team up like with my friend, but he's quite ill. So I don't have a group and I wanted to say like I can replace inactive people if you are willing to take me, like anybody available. I will not be inactive.
Okay.
yeah, you can
I'm
join my group. I think
actually,
I need
I actually
activeness in my
also
group.
have a group, but we are just two in the group, so I don't know.
Please, I need
I
activeness in
don't
my group.
I can't see who is talking, so I don't know who that.
you don't you
Okay.
don't you
I
don't need
am.
to see who is talking. I just need activeness in my group.
Depends.
Okay. Okay. You know what? All every Nonsi, Izu, Abdushako, Chito, you guys should like take this discussion to the channel. So
Discord,
let
yeah.
us now
Like let her drop a
exactly
message on the Discord, yeah.
drop. Okay, Nonsi, you can
Okay,
drop a message right now on the Discord. So I think it's
okay.
better that way to for everybody to reach out. So if you
Thank
so
you.
no problem. So aside from the general projects, if you aside from the compulsory projects, if there are still other people that still want to do other stuff. Don't limit yourself. Explore. Okay, probably you are doing a regression task and then, okay, you feel like you want to do unsupervised learning as well. You can also do that. And you feel like you want to do unsupervised learning, you want to do a major you want to do classification, you want to do regression, you want to do unsupervised learning. You are free to do it. Don't do it because of certificates. Do it because you are building your own portfolio. So that's basically what I can say. So yeah, thanks so much everyone for standing by. Please go through this the maximum likelihood estimation, the material, and then the basic of probability, the rest of the lecture. Go through it. If there are still stuff that you are unclear of, please just ask them, and then we'll try as much as we'll try as much as possible to answer them. You see, if back then, well, at the beginning of the course, when I felt like there are some stuff that were not explained in the lectures, I told us that we can have even evening sessions, but these evening sessions now, like having evening sessions is not really like it's because whatever I am trying to say has already been explained in the material. But if there's now an aspect that you don't understand, so please let's also bring it to my attention. Exactly. No, see, I've not seen your message on the channel. Have you dropped the message?
No, I'll send it now.
Okay, so drop it so that everybody I shall call you to can also drop a message so that whatever you guys want to cook, you guys can cook. And okay, anybody else?
So
I can see.
Yomife, regarding this project proposal form that we submitted, if we get new people in our team, can we update it? We can, yeah?
Uh it is it will be that will be in your projects. You just update it and then you will tell it will be no need to edit the project proposal. Hmm? So it will just be in the since you already submitted your project proposal and you are working with that same project, no problem. It's just that in your project, while you are submitting your project reports, you will tell us okay, and you will tell us that these are the people that were submitted in your project proposal, but in the project now, these are the people that's contributed to the project. Do you get? So, but you will reference that these people were in the project proposal, but when they due to their unresponsiveness, they were swapped with new members. Is that okay? Is that okay?
Yeah, that's fine.
Okay. All right. Okay. Cecilia, I've not heard you speak since morning. The Elijah is silent today. What happened? Millicent, I'm seeing Millicent on Monday for the first time. Oh, okay. Oluwabumi. All right. Any other contribution before we drop off the call? Oluwafemi. Feel free to unmute yourself.
No contribution. I'm good. Thank you.
All right. What about you, Bumi? Oluwabumi.
None. Thank you.
Okay. Elijah, you are silent today. Hope all is well. Okay, all right. I'll catch you guys. Okay. All right, Elijah. Okay, catch you guys on the Discord channel.
Bye.
Enjoy,
Have a
yeah,
lovely
enjoy the rest of your weekend. Bye bye.
week.